Oh, great. Yeah. Awesome. Hello, everyone. Hello, React Rally. It's awesome being here. Yeah, so my name is Justice Mba. They're just on Twitter, and I am from Nigeria. Hello, Nigerians back home. So, yeah, I'm really passionate about learning new stuff and teaching these new things, also helping people to grow. That's why I really enjoyed Pretty's talk in the morning. It was really difficult growing up as a developer back then. So, also bring changes to wherever I find myself in. And this is my first time in the United States. This is my first conference ever, and the first time speaker. Thank you, React Rally, for making this possible. Thank you so much. So currently, I'm helping the team at VConnect to overhaul the entire system using React. It's a huge work. VConnect serves over 1.5 million users in Nigeria every single day, so I better be careful with that. So, and I must say a very big shout out to React Router version 4. I mean, these guys got the team to loving React, like really, that thing really works. So thank you, Ryan Florence, Mark Jackson, thumbs up. Thank you. So, sorry about it. Great. So, yeah, I'm here to talk to you about setState. And I'm super excited to be the one talking to you about setState this afternoon because this thing has been one of the very controversial topics in the ecosystem, right? I mean, the frequency, the amount of time people bump into bugs trying to use setState, it's making setState kind of a mysterious box. That's why I'm here to demystify it, right? So this talk is not about when to use setState and when not to use it, or use Redux or not use Redux. No. This is to help you understand setState really deeply. So let's get it started. When I was preparing for this talk, I asked myself, what is React? So then I went to the official website. It says a JavaScript library for building UI. So React is really about UI, right? A way to think about UIs and build UIs, yeah. So then, what is UI? How do you think about UI? How do you reason about UI? So in his document on describing the meta model behind React, Sebastian Markberg has this, and like what it says that the core premise for React is that UIs are simply a projection of data into a different form of data. The same input gives the same output, a simple pair function. That makes a whole lot of sense, right? So let's think about it. Some of us coming from the web, we understand this fundamental concept of describing our UI using HTML markups, something like this. Then we pass this HTML markup to the browser processes it and outputs the underlying DOM elements or the UI elements. Now using this UI element, the browser does the CSS and layout thing and then push the whole thing to the screen, and that is our UI, right? So it's more complicated than this, right? But then it turns out that the most basic building block of every UI is the UI element. In case of the browser, that is the DOM element. So this is just a simple data structure that describes what the UI will look like. So that's why in React, we don't do HTML or templating of any sort. We just go straight using this same simple data structure, a simple plain old JavaScript object to describe what our UI is going to look like, right? So this element is going, or this JavaScript object is going to contain the type of the UI we're describing and also the properties that this UI is going to have. So this UI element also, or this simple JavaScript object, is what we call is the UI element, React element, the virtual DOM. Talking about the virtual DOM, I'm really not comfortable with that term, really. First of all, the term virtual DOM is broken, right? It's sort of a misnomer. First, virtual DOM is not just about the DOM, right? UI elements is not just about the DOM, but UI elements in general, wherever UI could be found, be it in VRAR or native, or wherever the UI could be found. That is what we're describing here. But that aside, my main problem with this term virtual DOM is that it kind of distorts people's mental model on how React really works under the hood. People tend to think that React keeps one full-blown virtual DOM, a kind of one mighty JavaScript object that represents everything on the screen. And that's not, look at how this innocent tweet puts it. Don't care about the rest of the tweet. Full virtual DOM is faster than creating full DOM. But man, there is no full virtual DOM. That is the problem, right? It's not his fault. I also had this mental model when I was learning React. As a matter of fact, I was having lunch with Henry and Michael yesterday. Not Florence, the other one. And I asked them the same question, what their initial thought was about virtual DOM. The first time they saw that thing, I really had really funny answers, right? So I started kind of thinking, if this word virtual DOM is giving us so much problem in understanding how React really works under the hood, why not stop just using it? Just stop using it and replace it with something like, I don't know, something more interesting anyway. But if you had that mental model about virtual DOM, please, after this talk, know that virtual DOM is not just about the DOM, right? It's not the entire UI. There is no full virtual DOM. So virtual DOM is just a fancy way for saying UI elements. Yeah, UI elements that are usually returned from a component, as we're going to see shortly. So moving forward, because we are super programmers, right? Our UIs tend to be very dynamic, not static like this. So it's not very practical to write out to type out our UIs like this. We need a more powerful system that will take in data and display dynamic UIs for us, right? So it's not really practical to type out our UIs like this, so we need something like a component, right? Where a component is simply a pure function that accepts arguments called props and returns the description of the UI in form of a JavaScript object. So this is not how we typically write our components, right? We don't return JavaScript objects like this. We write JSX or equivalent to JSX. But I'm focusing on the JavaScript object that we are returning, that JSX will transpile to whatever. Because this is the main focus of this talk. This UI element is the main focus of this talk. So this is awesome, right? Now our UI in React is able to accept data and project dynamic UI. That's awesome. But then it turns out that the dynamism of UI doesn't just end in accepting live data and projecting these live data. I mean, when our UI is projecting data or accepting and projecting data, it's only projecting data from maybe the server or wherever the business logic is coming from. So what you're seeing on the screen right now is 3 UI projections, hello justice, large justice, justice. So this state, justice, probably is what the server, the state of the server that is probably the current signed in user or logged in user that we are projecting, right? So if we have like 1 million of these projections on the screen, and all these projections needs the same data from the server, they are all going to be projected. And if the server alters the signed in user, probably to Rian Flores or somebody more awesome, the whole UI projection is going to be altered at the same time, right? But then UIs have states. UIs have their own states, and their states are not shared among other UIs projection. So what you're seeing on the screen right now is 2 UI projections of the same type, right? One is focused, and the other is not focused. And when the other one gains focus, the other one will lose focus. There is no way these UI projections, these 2 UI projections, although they are the same type, there's no way in the entire life now or the life to come that these UI projections are going to project the same state. It does not just happen. Their states are internal. Their states are self-contained. They are stingy, sort of. They don't share state with any other one. So if this makes sense enough, then in React, we also need a way to keep states. And that brings us to component classes. Component classes are simply a different way to define our components, but more powerful way to define components. And that's because we are able to keep states and also return some UI, some JavaScript representation or objects that describes what the UI will look like. So awesome, now we are able to keep states. Our UI is able to keep states. If our UI is able to keep states, or if our component is able to keep states, you should also be able to update states, right? And that brings us to setState. That part we've all been waiting for, yeah. So what is setState? setState is simply this awesome method that React gives to our component classes to update the states. That is setState. Thank you for coming. Please don't go ahead. So really, yeah, that's it. It's kind of React telling our component class, say, hey, component, if the UI, if you feel that the UI needs to be updated, if you feel that this current state you're projecting needs to be updated, use this method to tell me or to alert me to update the state. And also tell me what part of the state do I need to update and what will the current value be? So we pass this information using JavaScript objects, something like this, right? So when that eventually happens, when our component tells React to update the state, React will pick that JavaScript object that we pass to setState, to setState method, use it to update the state. Now the state has been updated, right? We have some new data in the state. React needs to figure out a way to update the UI, right? How will React do this? To answer this question, we're going to see a conversation between React and our component class. I don't know, I think it might be interesting, but if it's not interesting, just forget about it. So this conversation between React and our component class is going to help us to understand the fundamental thought process that went between these two guys that led to the initial render of our app, or of our UI. So basically, I want to describe the initial render of our components right now. So let's think about this UI, for example, right? We have four different components here. We're just going to focus on one component because the same thing happens in all the components, right? Now, before that, think of React as a project manager that understands everything about the project, all the requirements of the project, and then the rest of the components to be some UI team. So in our different companies, we have this guy, maybe the team leader or the project manager that understands the project and come to you, say, hey, Justice, we have this new requirement. We need a UI for this. Please help us out. And we go on banging on our keyboards, right? So React also will work from the first guy in the component tree down to the last guy, passing them requirements in form of states and props and asking them, what will the UI be like given these states and props? So the same thing happens, but we're going to use one probably header component right now for an example. So it will be like something like this. Hey, these are current requirements, the states and the props. Please tell me, how will the UI look? Then the component will return, see what the UI will look like. A JavaScript object that describes what the UI will look like, given the current states and props. Then React does something interesting. It goes to the memory and saves this rendering, this JavaScript object that describes the UI, and then takes a copy of it, goes to the DOM, and flushes it there. That is our initial rendering of the app, or of the component. Then this component, at a time, for some reason, decides to call setState. So what happens? Reconciliation. So these are just some big words, right? The concept is really, really simple. Because the component has rendered before, this is what React will do now. After React updates the state, React will go now to the component again, say, hey man, I've updated your state. Tell me right now, with this current state that I've updated, what do you render to? The guy returns a new rendering, which is a JavaScript object again. Then React does something very interesting. It goes to the memory, it pulls up the initial rendering, the initial JavaScript object that this guy has rendered before, and does what? Throws them into this magic dipping box, right? So this is just an algorithm to compare the two rendering, the previous JavaScript objects and the new one, just to find out what has changed. So the dipping box will now say, these are the changes, the diff, right? So React will use this information, this diff, go to the DOM, manipulate just those tiny parts of the DOM that needs to be manipulated. So ladies and gentlemen, this is what happens when you setState. So if you've been in this community for a while, you probably have heard that React has a setState problem, right? So we're going to be looking at these behaviors right now. We're going to be diving deep to understand what these behaviors are that has given people so much problems in hitting setState. Look at this first one. So you have this method in your component class where you attempt to update the state, then immediately you attempt to use that current state value. Then, sorry, wrong state, right? What is going on here? Why did React not just update the state for me at this very time, right? Now you're mad at React. Composition. So it turns out that most UIs we build are just a ton of composition of different components to make a very powerful and complex component. Something like this. Here we have these three components, the header, the main, and the footer. Then we have this parent component, the app component that composes everything together. Now think about it. When this app component, for example, focus on app component now. If app component for any reason decides to update the state, React goes and updates the states and come back to the component, the app component, and ask him what he renders now. This is what happens. Pay closer attention, please. So what do you render to now? Your state has been updated. The guy returns what he renders to. Okay, React will dig in. He needs to create some div. He goes to the DOM and creates some div and come back to the rest of the tree. Man, this guy has got 3 kids, 3 children, right? So React wants to go to the DOM now to do something, but there's a problem. React is seeing this header thing. React does not know what that is, right? Because it's not a string as usual and it's capitalized. That means that it's a custom thing that only the programmer understands. So React with no attempt to go and find out who the header component is, taking these props to him whenever he finds him. Here he finds him. He gives him the props, say, man, I've got some new props for you. What do you render to now? The guy returns something. And then React, because this guy has rendered something before again, React goes to the memory and pulls up what he has rendered before, throw them into this diffing box, and the diffing box says, oh, nothing has changed. So React goes back to the next guy, type, main, strange to React again. He goes to find him again, carrying the props. Hey, main component, here you are. What do you render to now? He returns this. React goes to the memory and pulls this up, the initial rendering, throw them into this dipping box again, and the dipping box says, something has changed. React goes to the DOM, manipulate the DOM. React goes to the next guy again. So this is becoming very, very boring, right? I don't know if you're enjoying it, but I'm really, really bored right here because React is doing the same thing over and over again. So I purposely did this so that you understand the amount of work React does every single time you setState, right? Super, super annoying hard work, right? So the React goes to the last guy, the footer component, Go find him again, carrying along the props. Sees him here. The guy returns something. React goes, pulls the initial rendering up again, compares it through. Something changed. React manipulates it down again. So, what all this then mean is that if setState was synchronous, if React had immediately updated our state at this very time, that means that this whole reconciliation thing will run from the beginning to the end, right? That makes sense. But then that further means that if React encountered multiple setState calls, say 5, 10, or 100 setState calls, that means that this whole reconciliation thing is going to run 5, 10, or 100 whole times. And God knows that that would be so stupid, right? We shouldn't be sitting here right now talking React. So for that reason, setState needs to be asynchronous. So when our component is telling React to setState, in a sense, it's making a request to React, not an immediate command to set the state, right? So it looks something like this. Hey man, please, can you help us to update the state? We need to update the state right now. Then React will be like, just keep doing what you're doing. I'll update the state at the right time. I mean, just continue doing what you're doing. Give me some time, I'll do that. Then our component will go on doing whatever suits him and run from beginning to the end. The last code in that life cycle, at this time, being an attempt to use the state, still reading the wrong state. So now that the last code in this life cycle is completed, to React, this is the right time to update the state. But how will React update the state? Batching. So it's really simple. It simply means that React will go to the multiple setState calls, picks up all the objects that has been passed to these setState calls, and compose them together into one single object. The code looks something like this, right? Then with that single object, React is going to update the state just once. One update means one reconciliation. Just one update, one reconciliation. Isn't that brilliant? That's awesome. But that comes with a price, though. If you are attempted to update the state based on the previous attempt to update the state, because these objects are batched together, the second update will still be reading the initial state. And then you will still be having this problem of state not being updated, right? So to prevent such mess from happening, React gives us this other alternative. By default, the React does has this now as the default way to update the state. I call it functional setState, where you just pass function instead of object to setState, right? And the function will receive the previous state and the current props, and then return what the state will be like, right? Then when this happens, because there are no more objects to batch together, React has something else to do. It collects all those functions passed to the multiple setState calls and queues them up. After that, React will go on updating or calling those functions, passing them the right state at all times. That means that even if you have a million setState calls in your life cycle, you are sure that you are going to be getting the right state just as you had expected. So it turns out that the idea of making setState asynchronous is really a brilliant one. In fact, I can't get a word for it. I call it async awesome setState. Really a brilliant one. So earlier we saw that whole reconciliation voodoo, that magic that React does every single time you call setState to update the UI. So what if React has the power to do something more interesting during the reconciliation process, like pause the update or destroy the update, do something more interesting. So the whole fiber, I'm not the best guy to describe fiber to you right now. But the point is that with fiber, React is able to unleash the full power of setState, right? React is able to do something like delay off-screen rendering. That is, delay the rendering of components that are not yet on the screen, right? React is able to split updates, prioritize updates, post updates, abort updates. And these are just mind-blowing, right? Awesome. So I could go on and on talking about the beautiful ideas behind making setState asynchronous. But we're going to go for a break, right? If you have any more questions, or if you feel that there's anything I can help you with, please feel free to contact me, DA Double Jobs, on Twitter. I'll be available till the end of the program. Peace out.